Power. Power is the rate at which work is being done or the energy that is being dissipated. Remember that power is the work done at certain time. We can also rewrite it as the force times the displacement over time. Because displacement over time is velocity, we can also use this relationship. Remember that power is measured in watts. So let's solve an example. Estimate the minimum power required to lift a mass of 50 kilograms of a vertical distance of 12 meters in 5 seconds. The data we have is the following. Mass of 50 kilograms, distance of 12 meters, and time of 5 seconds. Using the relations that we have to find power, we know that power is work over time, but we don't have work, so we can substitute it by the relation 4 times distance over time. Now, remember that we are going to use that power to lift a mass. So the force that has to be done to lift a mass is the weight of the object, and the weight is mass times gravity. So we are going to substitute force for mass times gravity, then the distance and time. So here we have the force, here we have the distance, and here we have the time. It's the same relation. Now we are going to substitute. The mass of the object is 50 kilograms. The acceleration due to gravity is 9.81 meters per second square. The distance is 12 meters. And the time is 5 seconds. Check that in our answer we are going to need only two significant figures. So the calculation from the calculator is 1,177 watts. But we only need an answer with two significant figures. So the final answer is 1,200 watts. Now, what is efficiency? Efficiency is the ratio of useful work or power to input work or power. We can see more clearly here. So efficiency is the useful work out divided by the total work in. It means that we are going to get all the work that was used in a system. Or if we are referring to a power, we have to divide the useful power out by the total power in. Again, we are going to consider all the work or power that is getting into the system and the one that is used. And this one that is used is the efficiency of the system. Let's solve a problem. A 50-kilogram battery-operated toy train moves with a constant velocity of 0.30 meters per second along a level track. The power of the motor in the train is 2 watts, and the total force opposing the motion of the train is 5 newtons. Determine the efficiency of the train's motor. We're going to set the information that we have. So as the information, we have the mass, 0.50 kilograms, the velocity, the power, and the force that opposes the motion of the train. Now, from the concept of efficiency, we have that the efficiency then is the total power, the power out, and the total power in. We know that one relationship to find power is force times velocity. So we're going to use this to find the power out. The power out is going to be force times velocity, and the power in, we have it from the problem. When we substitute the information, we have that the force is 5 newtons, the velocity is 0.30, and the power in is 2 watts. Check that in all the quantities we have two significant figures. So the answer for this is 0.75, and we translate this to a percentage, which is the efficiency of the motor. power equals